Let's take a closer look at our trig functions now, using some of the information we've gathered and looking at the unit circle. The domain of our trig functions is the set of all values we're allowed to plug in, all the thetas, or if we're doing real numbers, all the t's that we're allowed to take the sine of, the cosine of, etc. We can infer from the fact that we can go around this circle as many times as we want in either direction, positive or negative. The domain of sine is going to be all real numbers, or negative infinity to infinity. So we can plug anything we want to in there for sine. The same goes for cosine. Where we run into problems are these functions that have fractions or denominators, and we can't let the denominator equal 0. So in the cases where your x value is 0, and that would be at pi over 2 and 3 pi over 2 and every circle beyond that, tangent cannot have a pi over 2, 3 pi over 2, or any multiple of circles above and below that. One way to represent this is to say theta, or if we're talking real numbers, t, cannot be pi over 2 plus or minus k pi. K meaning any integer. So you can't be 17 pi, that would land you down here, or pi over 2 minus 40 pi, which would land you right back here again. This tells us that the x values can't be 0. And since secant also has x in the denominator, secant will have the same domain. The domain of secant is theta cannot equal pi over 2 plus or minus some multiple of pi. Looking at the definitions that have a y in the denominator, y is 0 whenever we're on the x-axis, or in other words at 0, pi, 2 pi, 3 pi. Going the other way would be negative 4 pi, negative 5 pi, negative 6 pi. So we're not allowed to have a theta, and this is given cosecant or cotangent. We're not allowed to have a theta that is a multiple of pi. Now let's consider the range of these functions. For sine and cosine, we can see that since they're just the x and y values, our x values go from negative 1 to 1 inclusively. So the range for cosine is going to be negative 1 to 1. The range for sine is our y values, and the y values for the unit circle go from negative 1 to 1, so it's also got a range of negative 1 to 1. For tangent and cotangent, these are ratios where the numerator runs between negative 1 and 1, and the denominator runs between negative 1 and 1. Now what happens when this x value gets closer and closer to 0? That's going to make this rational expression get larger and larger, whether it be positive or negative. So with the tangent and cotangent, the range is going to be negative infinity to infinity. With secant and cosecant, these are a little harder to visualize. The range of sine and cosine is from negative 1 to 1. Secant is the reciprocal of these. So the reciprocal of negative 1 to 1. Well, the reciprocal of negative 1 is negative 1, so that's a possibility. The reciprocal of 1 is 1. But the reciprocal of a number between negative 1 and 1 is going to be a number that's outside of that. It turns out that the range of secant and cosecant is from negative infinity to negative 1, and from 1 to infinity, and that becomes because it's the reciprocal of sine and cosine. Let's consider some more aspects of the trig functions. Looking at sine of pi over 6 and negative pi over 6, we see that sine of pi over 6 is 1/2, and sine of negative pi over 6 is negative 1/2. This is what we call an odd function, not because we think it's strange, but because a function is odd if by changing the sign of the input, it gives us the same numeric value for the output, only the opposite sign. This is what we call an odd function. In terms of trig functions, the odd ones are the ones that have a y in the definition. So this is going to be sine, cosecant, tangent, and cotangent. In all of these cases, if we negate the input, the angle or the real number that we put in, it's just going to negate the output. In other words, tangent of negative theta is going to be negative tangent of theta. So if somebody tells me that tangent of some angle is 5/13, then that tells me that tangent of negative of that angle, without knowing anything about the angle, I know that that's going to be negative 5/13. Now let's consider cosine. If we look at cosine of pi over 6, square root of 3 over 2, and cosine of negative pi over 6, well, that's also the square root of 3 over 2. In other words, by changing the sign, SIGN, of the input, we did not change the output at all. This is what we call an even function, where by changing the input, it does not change the output. Or in terms of trig functions, cosine of the opposite of theta is going to be the same as cosine of theta. And this turns out to be the case for any of the trig functions that depend only on x. Because notice, for any angle, no matter whether we're in the first or second or third or fourth quadrant, for any angle, by reflecting it across the x-axis, in other words, by negating the angle, we don't change the x values. They stay the same, whether they're positive or negative to start with. So these are what we call even functions. So our even functions are cosine and secant, and our odd functions are all the others, sine and cosecant, tangent, and cotangent.